Now, if you actually look at this carefully, both the original code and the asynchronous code will take the full 5.011 seconds to run, right? Because there's no way to avoid the 5-second wait for the database, right? In the original way, you just wait while you're stalling in the HTTP handle HTTP request function. In the new way, you're waiting, you're still waiting 5 seconds. So if I asked you, how long does the, which one is faster for one query, one request, it doesn't actually matter which one you use, right? Because no matter what, the database will take 5 seconds and you can't get around that. There's no way to get around that. Okay, but the real advantage in asynchronous programming comes when you have multiple requests. So I just copied the code below for asynchronous, which is the database lookup async, right? And then 5 seconds later, it runs the finisher. So it kind of breaks the code into the setup, calling the asynchronous, and then waiting 5 seconds. Okay, so let's say that our server has 3 requests that come in at pretty much the same time, A, B, and C in quick succession, right? 3 clients. Here's what happens in the original code. I don't have the code up because I don't have space, but remember the original code just has 1 thread. The A comes slightly first. So A gets to run the whole time, 1 thread only, right? There's no multi-threading. So A will hog up the server for a little over 5 seconds. Now B and C in the meantime have to wait. B and C came in right after A, but they have to wait for their turn. Now B runs, takes 5 seconds. Now C runs, takes 5 seconds. So this is pretty annoying because, well, A is optimal, right? You can't speed up A anymore because A has to take 5 seconds. But B has to wait 10 seconds before their query finishes. And C has to wait 15 seconds before their query finishes, even if they were just slightly later. They're nearly simultaneous. Just because A beat them, beat B and C to the punch slightly, A gets to finish in 5, B gets to finish in 10, C gets to finish in 15. That just seems really annoying to B and C because they weren't that late, right? They understand that they have to wait the 5 seconds because it's a slow database, but they shouldn't have to wait 10 or 15 seconds. So here's what happens in asynchronous mode. First of all, A runs and it finishes pretty much instantly because if you look at handled HTTP requests, it finishes in 0.002 seconds, right? 0.001 plus 0.01. Because the database lookup async function finishes instantly, A is done, right? A is done because by 0.002 seconds, A has told the database to do its thing and come back and run finisher 5 seconds later. So that means that B can be handled right away. B is handled right away, dispatches the database, and it's done. And now C is handled right away. Dispatches the database using database lookup async, and it's done. So A, B, and C are done pretty much instantaneously. These boxes are kind of wide because I couldn't draw them super narrow because I need to fit the letters. But imagine they're done all within, 0.001 something seconds. Okay, so now 5 seconds later, this line means 5 seconds. 5 seconds later, the database is done, and the finisher for A runs, and now A finishes and sends the data back to the client. Okay, that's great. So A took 5.01 seconds to run, which is what we expected even in the original case. But here's where the advantage comes in. 5 seconds after B dispatches the database returns for B, and now B can run and finish and send the data client. And then 5 seconds later, C can run. So notice how the 5 second gaps are overlapped to a large part. So now everybody is done within, let's say, 5 seconds, right? Give or take a few milliseconds. Now this, of course, is assuming that your database is scalable enough to handle multiple queries at the same time and still be okay. And we can, database design is outside the scope of this set of lectures, but imagine the database can scale, that you can actually send multiple simultaneous requests. So in this way, you can have a single threaded server send multiple nearly simultaneous requests to the database, and then get everybody, A, B, and C, to finish all within 5 seconds. And the trick here is that you're actually dividing the work into 2 stages, the stage before you do the database lookup and the stage afterward. And in between, you're releasing the server to handle other requests. So that's why A, B, and C all finish around 5 seconds, which is optimal. Whereas in the original way, whoever gets there first just hogs up the server for all 5 seconds and everyone else has to wait. Okay, so that's exactly the recap of this. Asynchronous programming allows the server to process 3 requests concurrently with only a single thread of execution. So it's concurrent, but it's not doing anything in parallel. There's only one thread of execution. And the trick there is that it's dispatching to some special asynchronous function in the database that will tell it when it's finished and then when it should run the finisher function. This sort of style happens in the web browser as well. It's not just for servers. Okay, imagine that A, B, and C are 3 user input events in the browser. Imagine that A takes a long time, which is like fetching data from Facebook, right? You might want to press a button and get some data from Facebook, and that might take a while. It might take a few seconds because, if they're busy. But B and C are really fast. B is like, changing some animation on the page. C is like a mouse click handler. They're very fast events. B and C are instant. But A takes a long time for some reason because, doing some thing A in your web browser might have to say fetch a bunch of data from Facebook. Okay, in the original way, here's what happens. The synchronous, the regular way is A comes in first. It takes the whole 5 seconds. It freezes up your browser and works for all 5 seconds, right? During those 5 seconds, your web browser can't, the loop can't do anything else. It's just frozen there waiting for Facebook to get data back to it. That's clearly bad. And now B and C are almost instantaneous, but B and C both have to wait for 5 seconds for A to be done, just because A came in a little before. So this is not a great user experience, right? Because B and C should have been handled right away, pretty much. But we've had to wait for A because there's only one thread. So in the asynchronous mode, very similar to the server case, A runs and it's instantaneous. And it basically goes to Facebook and says, when you're done fetching data from Facebook, call a finisher function. So it's finished almost instantaneously. And then now B and C get to run pretty much instantaneously. So there's no lag, basically no lag in running B and C. And now B and C finished instantaneously, and then now 5 seconds later, A finishes, right? But that's unavoidable because the getting data from Facebook, let's say, takes 5 seconds. So there's no way to shave that time at all. So A still takes the original 5 seconds, but now the difference is that B and C get a chance to finish right away so that your browser doesn't lock up waiting for A because there's only one thread. So again, the asynchronous lets you split up the work of A into these 2 phases that are 5 seconds apart. But in the meantime, you can let other tasks run, such as the fast running B and C tasks. So again, in the first example, the browser freezes for 5 seconds while handling A, which is clearly bad. Second example is that the browser always feels responsive to user inputs. B and C are instant and they're just there. They just work. So in general, in a web browser, you don't want to lock up you don't want to do something that locks up the loop so that you can only do one thing at once. You want to do these asynchronous things so that you want to free up the main loop so that other tasks can run and other events can be processed. To perform asynchronous programming, you want to pass what's called a callback function into special functions that are designed for this style. So a callback, the finisher function in this example is a callback because it's just a normal function. It's called a callback function because it's literally, this is the function you want to call back, right? A callback. You want to call back when you are done looking up something in the database. A very common thing is to use an anonymous callback function, so the bottom variant. Basically, it's the same code as the finisher, except it's defined inside of the database lookup async call. So it just says parentheses result, arrow, braces, and then the finisher function. So the anonymous one's nice because it prevents you from having to define to create new names. So you often see this in code as callback functions. And this is why I covered the double arrow, the equals greater than arrow syntax. So you're going to see anonymous functions a lot and callbacks, both in the server and in the client. But just know that callback functions are nothing special. They're just functions that you happen to pass into these asynchronous functions as arguments. Okay, so recap of asynchronous programming. So asynchronous programming is very widely used in both web servers and browsers to try to do more than one thing at once. It allows servers to handle concurrent requests faster and also allows browsers to be more responsive to user inputs. Remember, these are single-threaded apps, but it kind of gives the illusion of multi-threading by allowing you to dispatch something slow far away and then to call you back when it's done. So it relies on passing what's called a callback function into specialized functions that were designed with asynchronous programming in mind. So in order to do asynchronous programming, you actually need to use a library or a framework that supports asynchronous programming so that you program in that style by passing callback functions.